So we've got Boyle's law and Charles' law, and notice V1 and V2 are in both equations. Okay? So what we want to do is to put all of this together. So the combined gas law is P1 V1 over T1 equals P2 V2 over T2. Okay? With Boyle's law, we had to have 3 out of the 4 values known in order to solve for the fourth one. In Charles' law, we had to have 3 out of 4 values known to solve for the fourth one. What do we have to have here? How many variables do we need to know? How many values do we need to know here to solve for one of those values? 5 out of 6. We've got to know everything but the last one. Okay? Now, before I go too far, I want to be real clear about something. I sort of set it up to make it easier for you with Charles' law before. You need to know that you cannot solve gas law problems unless temperature is in Kelvin. Okay, so temperature must be in Kelvin. All right? And you also need to know then the conversion between Kelvin temperature and degrees C. Okay? And if you look on your test references, you got this little simple equation right here. All right? If you're given a temperature in degrees C, you add 273.15 to that to get the temperature in Kelvin. So if you have the temperature in Kelvin, how do you find degrees C? You just subtract the 273.15 to get there. Okay? You could do the algebraic substitution if you wanted to, and solve the problem, but basically it's pretty simple. 273.15, and it's on your test references. Now, I'm not going to give you a question here in degrees C, but you need to know that if you had one of those, that's what you have to do. You have to add and subtract 273.15 to find the correct Kelvin temperature to solve these problems. Okay? All right, so let's do this problem. Whoop. I'm using ATMs, okay? So let's increase it to 1.0, let's say 85 ATMs. Okay, so gas has a volume of 47.65 milliliters, has a temperature of 325.0 K, and is under a pressure of 1.40 atmospheres. That's a 4 and a 0, 40 atmospheres. And if the pressure is increased to 1.85 atmospheres and the temperature is decreased to 300 K, what will the gas volume become? All right, you're going to solve these problems all the same way. Make your list of knowns and unknowns. What now?
Nothing.
Okay. Make your list of knowns and unknowns. This is a class assignment. Everybody should be making their list of knowns and unknowns right now. So go through the problem and find the list of knowns and unknowns and make your list.